right, let's get started. Hi, I'm Kareem Kouddous. I'm currently CTO and founder at Crowdtap. I'm also a side project addict. You can find me on GitHub and Twitter at Kareem K. So Ruby is cute, and what I mean by that is, it's optimized for developer joy. I mean, anyone who attended Matt's keynote, could feel that. And I personally wanted to go up and hug him after the keynote. It's so clear that, the genesis of Ruby came from a place of wanting to create joy in what you do every day, happiness in web development. And Rails arguably could be cuter. Rails took those same principles of really loving what you do every day as a web developer or software engineer and taking that to the web stack. And I'm sure all of you remember the blog in 15 minutes, and that was magical because it was so painful before to get a web application up and running, and Rails changed everything. But I'm sure, as a lot of you also know, over time as your team grows and you start to actually build very interesting features, things start to get difficult. Tests start to take a long time. There's great testing ethos in the Ruby community, but you have a lot of tests, you build a lot of features, and things start to get slow. And what does that do? Instead of being able to push out code into your staging or production environment immediately, you have to wait, minutes, maybe even hours before that gets in there, and you lose flow. You have to context switch. That's horrible. Your fat models become obese. Suddenly, you have 6 engineers touching your user model, and people are repeating the code all over the place because they're trying to do, something that's the same but slightly different. And, instead of trying to refactor the app, you want to push features out, they're duplicating code. And these things become really hard to work with and less joyful. You start to use a lot of gems, and that's great. That's one of the wonderful things about the Ruby community is there's a lot of us, and we've contributed so much to it. But then your app starts to take a long time, and you're building an interesting application, so it has a lot of features, and you have a lot of gems, and that takes a long time, and you stop experimenting. You stop just booting up console and trying stuff. That joy of that first experience with Rails or Ruby, starts to erode. And then hugs turn into yelling. Right? You're in your chat room just trying to figure out what's going on and yelling at each other. It's no longer joyful. And fundamentally what that means is you've lost your agility. And I think that's what Matt was really trying to say is agility is about happiness, right? If you're happy and free to do what you want with your code, you're going to innovate. You're going to do interesting things. You're going to be creative. And as your app grows, though, this starts to change, and you lose your agility, and we're back to, waterfall, but just in a, same pain points, but just manifested in a different way. So, what was really cute, suddenly is this really scary, ugly thing that has appeared in your life, and you don't know what to do with it. You want to figure out a way to solve this. And so you need to figure out what the root cause is, right? That's how you solve problems. So you need to figure out the root cause and solve this problem. You want this guy out of your life. So to illustrate that, I'm going to go through how this manifested itself, this problem, this beast, at Crowdtap, and walk through that to show how we got to where we are now. And I'm going to start by just giving you a quick overview of what Crowdtap is. We're the leading social influence marketing platform. We let big brands collaborate with their customers, which inspires advocacy and drives unmatched social activity. And what all this marketing speak boils down to is we create awesome tasks, engaging, fun tasks that brands launch, that users complete to help brands market. And those tasks span the full marketing lifecycle, everything from completing a poll to taking a photo of doing something fun and sharing that on Facebook, to getting free product from the brand, sharing that with friends, throwing a party around it. And we're constantly adding different tasks, fun, engaging tasks, so that the brands can collaborate with their consumers to market instead of just shouting at them. And that's what our vision is for Crowdtap. So let's take a look at this, and a screenshot. And this is one of our more popular actions, which is a poll. Brands can get real-time feedback on whatever they want. And here they're asking specifically, what cable networks do the users currently watch or receive? And the really powerful thing with Crowdtap is we take all this data that that users generate from answering all these questions and participating with the brand, and we give the brands very rich and deep targeting ability, so that not only can they target based on all the demographic data on the user, their age, income, etc., which we collect, they can also target based on everything that user has done, the entire history of what that user has done with that brand. And they can also target based on what they haven't done. So it's a very, very rich targeting engine. But as you can imagine, this becomes a performance bottleneck very quickly, because on every page load, we need to know which tasks are available for a user. And if targeting, you can target based on anything that user has done. You have to load up the entire history of that user. And so it should be clear, this is a really big performance bottleneck. And this was the first pain point that we encountered, or a major pain point that we encountered, along with everything I was discussing. So we needed to solve this. And the way to solve this is, we need to tailor our data structure for the problem at hand. So what I mean by that is, we're generating data, everything that user is doing, and we're collecting it in a way from our main application that makes sense, when you're doing just basic CRUD. But then we want to take that data, and we want to have the freedom to denormalize the data, maybe put in caching, maybe use a different database technology. We want the freedom to experiment and explore with this data to be able to solve the problem. And at the same time, we want to do it in a way that takes us back to the joy, back to the little cute, fuzzy animals we had in our lives, and not these beasts, right? So how do you do this? So, the first thing we thought was, okay, we've been reading, people have blogged about this services. What about just extracting and this functionality into services? But that doesn't work, right? Because even if you extract your functionality into services, what you really care about is your models, right? That's your data. So we're not talking about extracting business logic, into single-purpose files. We're talking about being able to work with our data in a flexible way. And so extracting into services doesn't really help. And Rails, what about a Rails engine or gem extraction? Essentially, this is all the same thing. It's just moving furniture around. What you really want to do is be able to mutate your data. You want to be able to play with your data structure and have freedom there. And this brought us to, what about app extraction? Why don't we extract this into a separate app? We can go back to the little cute animal because it's a smaller app, and solve all of those other pain points, but at the same time have some freedom to solve the performance problem, which was a very big business problem for us. And so the first thing we considered is, how about extracting the app and sharing the database? Well, this doesn't work, right? Because everything you need to do with your data is in your main app. Your main app owns that model. And so if you're going to do anything interesting with your data, you're going to have to do it in your main app. So what have you done? Your targeting app isn't... The splitting up of the app is not solving anything, right? Okay, so let's do this. Let's do synchronous API. And this is probably what most people think of SOA, right? SOA is some RPC mechanism between apps. But again, this does not solve this problem, because if you're going to do anything interesting with your data and you want to mutate your data, you're going to have to do that in your main app. And so you're adding complexity to your main app. We want to remove complexity from the main app and put it somewhere else, right? And deal with it somewhere else. So this doesn't solve the problem. This just adds more layers. So I hope by now it's clear what the right way to do this is. And for us, it was. We need to have a separate database for our targeting application, and we need to replicate data from our main application into this separate app, and have the freedom in our main application to mutate the data as we wish, experiment with different databases, really go back to being agile in solving the problem. And that's what we did. And it's at that point that the heavens parted and Nico fell into our laps and helped us take this architecture to the next level. So I'll just pass this on to Nico.
Hello, how are you? My name is Nico. I'm a PhD student at Columbia University in the system department. I love open source, and you can find me on Twitter and GitHub at Viennot. So last year I came at Crowdtap, and they just extracted that targeting logic into its own separate app that we call Sniper. So that was a great win because we were able to finally see the big picture of this application, of that logic. And so when we extracted that, it was like 5,000 lines of code. And since we were on that app, we could really refactor it quickly because the tests were running in 30 seconds. And we got to a point where the app was just less than 1,000 lines of code because it got really intuitive. Oh, look, we should put our data structure like this. Oh, what if we generalize this way and all, which we couldn't do in the main application because everything was kind of coupled together and it was really hard to see, the big picture of things. So performance went really well after that. We went from, a second or two to 50 milliseconds. That was like, yay, big win. But we created another problem, which was data replication. And it's actually hard. So what we did first was something pretty naive. So on the main application, the publisher side, we're like, well, let's just add some callbacks and post the data to Sniper. And then Sniper, the subscriber, is going to be like, oh, I could take that data and save it to its database. But things started to break down in production. We're like, it's funny, the two databases don't have the same user count. It's weird. So we realized, wait, it's a distributed system. Things fail all the time. So for example, if your web server, right after writing its data to the database, dies and is not able to do the callback, then oof, Sniper doesn't know about it. Or what if Sniper is down? Well, it won't receive some updates for 5 minutes. So that's a problem. So we're like, okay, so this is a problem. And at the same time, we're looking at it, we're like, oh, that's funny. That looks really like an observer, like in the Rails sense, right? Like the subscriber is really like observing the data that is changing on the other app. And we're like, well, that's a cool concept. What can it do with it? And what we really want to do with that is to split our app in a lot of different services, right? Like if we could have those remote observer and replicate data around, we're like, well, why don't we apply the same sauce to the email service? But we couldn't just add callbacks and see the production system kind of like blowing away like this, which is why we introduced Promiscuous. Promiscuous is a transparent application-level, causally consistent data replication framework for service-oriented architecture. And I'm going to explain to you what it all means. So Promiscuous is essentially the glue between all your services. So you can think of it as a message bus where you're going to have services publishing their data, and then you're going to have subscriber apps who are like, oh, I'm interested in that model and this one and that, and it's going to do something interesting. And Promiscuous sits on your models, between the models and the database layer. So everything that the publisher would do, it's going to propagate those changes down to the subscriber models without having you to do anything. So that's Promiscuous in a nutshell. And because we are really trying to get back that joy and the simplicity of Rails and Ruby, Promiscuous had to provide those three key features. So first, it tackles data replication in a novel way, which scales and is actually consistent. It provides a very simple API because as a developer, we just want to write one line of code and be done with it. And of course, since we're Rubyists, we want a good tasting framework. So I'm going to go through all those 3 points. So data replication, it's pretty hard to get your head around this. But let's go through an example. So say you have some sort of Facebook app where you have users and they can send messages to each other. And so here, say I want to implement an email service that sends an email to whoever received a message, right? Simple. So here, if you would to subscribe to the data that is interesting, you would see, oh, a user just signed up, so you create user. And then that guy just sent a message to another guy. OK, create message. Great. So when you create message, you're going to be like, oh, fetch from my database. Oh, okay, I had that user. I can render my email. Okay, hi, whoever, oh, hi, and all that. But since we need to scale because we have a lot of users, we're going to add some workers. So that's what's going to happen. On your email service, we're going to have, say, 2 workers. And now, since we need to process this message in parallel, what's going to happen? Well, if worker 1 is a bit slow sometimes, maybe it's not going to process that create user quick enough to put it in the database. And so the worker 2 is going to be like, oh, who is that user? Oh, well, I don't find it in my database. Boom, exception. So that's the problem. And that's a consistency problem. But Promiscuous is going to solve this problem for you transparently without you having to do anything. And so it's going to try to parallelize as much as messages that it can, but still serialize the messages that are important. For example, the create user happens before the create message. And that's what we mean by causally consistency. So as in cause and effect. So let's see how that kind of works. So how is doing this transparently? So when you have a user that wants to send a message to another user, it's going to hit your controller in some ways. And your controller, what you're going to do, you're going to interact with your models. So what you're going to do, you're going to fetch, first of all, the current user from his cookie. And then you're going to do a user find on his friend. And then you're going to finally create the message with the foreign keys that go well. And since Promiscuous sits at your model, on your model, it's going to be like, oh, that's what you did. So he's going to infer that the message create depends on those 2 pieces of data. And that's how it's able to serialize the messages that are important and parallelize the ones that are not. So you could say, well, that's a bit overkill, because why don't I just retry until the user is in my database? Because you would have an exception, right? But it's actually more so than that. So let's take another example to illustrate this. So say you're on Facebook, and you have people posting pictures, and you want to implement an email service that send an email of the picture to all of your friends. So say you have a user, consider that scenario, you have a user coming back from spring break, and he deletes his parents from his friends list, and then he posts a compromising picture. Okay. So what happens if you reverse the processing of those 2 messages? Well, you're going to send the picture before having removed the parents. And you're not going to have an exception. You're going to have a phone call. So this is how, Promiscuous really has you covered. And you don't want to, when you're developing event-driven services, you don't want to think about all the races you could have and all that. Like, it's way too complicated. But we still want a very simple API. So essentially, Promiscuous is your main data bus, right? And it does so under the cover you have RabbitMQ, which is a message broker. So you're going to have publisher applications that are going to send their messages on RabbitMQ, and then you're going to have subscriber applications that are going to connect to RabbitMQ, and each of the services is going to have their own queue, and then going to receive those messages through RabbitMQ. So no subscriber actually talk to the publisher app directly. So you're going to have some good decoupling mechanism. And because we need to synchronize all the workers together, we use Redis. So for example, that worker is like, oh, wait, so before I can create that message, I need for you to wait to create the user. OK, I'm going to wait for you a little bit. Oh, you died. Oh, well, in that case, I'm going to process that message. So all of that is done through Redis. So let's see a bit of the API of Promiscuous. So on the top, I have a publisher application running with Active Record on ParkOS, for example. And on the bottom, I have a subscriber application running on MongoDB. So all I need to do as a developer is to include the Promiscuous publisher mixin and publish the field that I'm interested in. So for example, email and name. On the subscriber side, I'm going to include the Promiscuous subscriber mixin. And in my subscribe block, I'm going to put the fields I'm interested into. And that's it. That's all you need to do. That's the entire API. That's it. So of course, once you start developing this, you want to start testing that. And Promiscuous provides you with a testing framework. So for us, we believe that integration tests are extremely important. And we have to test our subscribers in a way that is decoupled from the publishers. So the publishers actually, so Promiscuous allows publishers to create a gem to publish a gem with factories that represent the kind of data that if you were to subscribe to their model, the kind of data that you would get. So to illustrate this, I'm going to show you a real test of Sniper. And you can see on the top, like, we just do create Crowdtap member instead of the regular create member. And so by doing this, Promiscuous is going to take the factory of Crowdtap and package the payload that you would have received for real in production and send it through your pipeline. And so you're going to be able to test really well your application as if it was in production. So to really demonstrate how easy it is to use Promiscuous, Kareem is going to show you a live demonstration.
Hello. Thanks, Nico. All right, let's show you guys how awesome this is. Okay, so what I'm going to do is I'm going to show you guys adding, taking one of our existing models on our on one of our apps and subscribing to it in another. So on the left side, we've got Crowdtap, and I've got one of our models that we're actually not publishing yet, which is package. And so we're going to take this and we're going to publish this model, and then on the other side, which is Sniper, on the right side, which is the targeting app we were discussing, I'm going to subscribe to that model so that any changes to the publisher app are reflected on the subscriber app. And I'm also going to put some callbacks in there to bind to any changes that are happening. So let's go ahead and do that. So all you need to do first is just include, the Promiscuous publisher, which Nico showed you in that API example, and then just wrap, whatever fields you want to publish in a publish block. And so in this case, you don't need to publish everything, and that's important. You want to figure out what's your API, right? And it doesn't need to be the entire model. So you publish what you want. So in this case, let's publish name and features, and that's it on the publisher side. And so let's go ahead and write the subscriber. So the only thing you need to do is create a model with exactly the same name. So package. We're going to store it in Mongo. Include the Promiscuous subscriber, so reflection of the Promiscuous publisher. And then mirror again the publish block with a subscribe block, and let's only subscribe to the name, just for this example. And then let's print out the name every time the name changes. Okay? So that's it. So that's all the code you have to write. So let's start up the Promiscuous subscriber and take a look at RabbitMQ. So RabbitMQ has an awesome admin API UI, and we just started the subscriber. There are no queues here, and we should see a queue any second now. Oh, I typed. There we go. So we have a queue in Rabbit. We're going to kill the worker. Let's go back to Rabbit. And this is a reason that we chose Rabbit is it supports persistent queues. And what that means is even if a worker dies, your queue is still there. It's durable. And any messages that would be consumed are buffered by Rabbit. And when you start the worker up again, you get those messages. So you guarantee that those messages are going to be delivered. And that's a property that Rabbit gives you. It's awesome. So let's go back and let's publish something. So first, let's just make sure we've saved this. Let's reload just to get those changes. And then I want to also illustrate how dependencies are tracked. So let's do a read. So I'm just going to read the last member that we have in our database. And then let's actually create a package. Okay, so there we go. We've created that package on Crowdtap. Let's let's pop over back to Rabbit and take a look at the payload of that message. And so here it is. So you can see a lot of metadata here. Types is the class we support inheritance. So you can publish an entire inheritance tree. You can publish embedded documents. If you're using Mongoid, that's all supported, which is very powerful. Obviously, the ID, the attributes that changed, the operation. Here's some more metadata. Importantly, the namespace. So it's the name of the app. Crowdtap. Some more information helps with debugging, like the host that it was published from. Current user, if you're in a controller and you're logged in, publish that. That's really useful for debugging. And then the most interesting part is the dependencies. So we did a read in console, and here's the associated dependency on that user. So here's the ID and the version. We use versioning to make sure that when this message is consumed on the subscriber side, that user exists in that exact state. So that's how we manage all the dependencies and do causal consistencies. And here's the right dependency, which is the creation, the object that we just created. So that's it. That's the payload. So let's go ahead and subscribe. And so what we should see here is hello world being printed out. Drum roll. Magic. Okay, so let's show update. Okay. Much easier to type when you're in your room than in front of people. Okay. Yeah. Okay. All right, sorry guys. Okay, well, for some reason this isn't working, but let me try once more. Okay. That's weird, I'm like typing. Okay, if I had typed any change, it would be immediately propagated over to the publisher side. And trust me, it works. I can show you after. So let's, so let's, what did this do to us? So we started, with these two applications, the main app, which is Crowdtap, and the targeting app, which is, Sniper, because it's targeting. And then we pulled out all of our analytics in Fiancé, Fiancé because it tracks engagements, obviously. And Bobby, because he's the policeman that makes sure that, when people are posting stuff that, it's not spam, and if it's awesome, that it gets starred. So, we can iterate on using, AI techniques here to moderate our posts. And then Paparazzi, is out there scraping Facebook and Twitter and gathering, data so that we can report on that for our clients. And then Casanova, generates CSVs, and it's Casanova because it works, because it spreads the love. I still don't get that name, but we have creative developers. And then email service Iris, which is the notification god, and then most interestingly is, at least in my perspective, is Captain Planet. And Captain Planet came out of a 2-day hackathon that we recently had, where a developer was able to, on his laptop, subscribe to the production database, production Rabbit, and generate canned reports off of that data to solve a really big pain point that we have, that our account team has, and actually do that in a completely isolated way that didn't impact the production system at all, and was actually running that on his laptop, just like the fire hose of production data, on his laptop, and did that in a couple of days and worked with it. That's joy, right? That's back to the joy of the 15-minute blog. That's taking a really complex system and making it, easy to use. And it took, this and went back to something ugly to a lot of little cute, fun, cuddly apps that we now have. And with that, I'm going to pass it back to Nico to wrap things up.
So to wrap things up, we've seen that Promiscuous is very useful to do event-driven services. So you can trigger callbacks to real time. For example, you want to send emails when some piece of data is changing. You want to keep your caches warm. Whenever some piece of data changes, you want to, instead of invalidating your caches, you can actually recompute the right thing. You could push data asynchronously to your browsers to improve the user experience. And we want to do all that also and also doing database replication, but different kind of databases, right? So I want to be able to replicate my Postgres database to Elasticsearch and maybe MongoDB and maybe Riot, whatever it is. And I want this to be decoupled. And I want this to do this at scale and with good consistency. So that was going to allow you to really see the data that you want for the feature that you need to implement. And so real time is really, really important these days. And if you can embrace the asynchronous layer of your application and to really unleash the power of your data, right? So you can really innovate now. You can hire some interns for a summer and get them to do some machine learning project directly in production without having you to be worrying about, oh my God, they're going to screw up my system and they're going to pollute the code and all that. Like if you don't like their stuff, eventually you just delete their app and you're done, right? So you can really go back to being agile and try things really without having, oh my God, I need to change so much things. Like you get back to really the agility of your team. So that's about it. So we invite you to try it out. It's on GitHub on promiscuous.io/promiscuous. So we've been using it in production for a year now, and we're very happy with it. But it requires a bit of babysitting for now. So we're still working on it, and we're trying to make it really a hands-free experience so that you can just plug it in and that you have nothing to worry about, and you have all the different recovery mechanism that kicks in at the right time and everything. So if you feel adventurous, you can try to extract your email logic out of your main application, because that's like the obvious, like, you have some, this is an observer really. And perhaps build some reporting service also for some of your fancy clients. So if you try it out, we'll be super happy to help you with to go through with Promiscuous. And you can find us on Twitter and GitHub, Kareem and Viennot. Thank you. And now we'll take questions.